In this video, we're going to look at kinematics with calculus. So we're going to take what we've been learning about derivatives, integrals, stuff like that, and look at how do we use that to describe motion. So jumping right into it, we want to review some key terms first. So kinematics is the study of motion. So if we've got things that are moving, we want to use kinematics to describe it. And the key terms in kinematics are first position, which is the location of an object in space. And if you'll remember, we talked about displacement is just comparing the starting and ending positions. So we don't care if you went back and forth 10 times. All that we care about is where you are now and where you were earlier. Distance is accounting for all that travel time. So distance would be like if you were laying down a string behind you and then measured how long that string was. Velocity is the rate of change of position. So if you take the derivative of position function with respect to time, so we'll add that in with respect to time, that will give you your velocity. And this is slightly different than speed because speed just cares about the magnitude. Velocity cares about the magnitude and the direction. It's a vector. Right? Because if you're speeding up in a specific direction versus a different direction, you'll have different velocities, but you'll have the same speeds. And then acceleration is the rate of change of velocity, again, with respect to time. Not a space there, but we fit it in. And positive and negative acceleration indicates direction. It doesn't necessarily mean speeding up or slowing down. And we'll talk a bit more about that as we get further into this video. So jumping into the next thing, if we want to express all these ideas with calculus, position, we can talk about a change in position as being equal to the integral from some initial time to some final time of the velocity function integrated with respect to t. And if we kind of play around with that as well, we can also say that it's the initial position. Sorry, I should not have it written with an equal sign there. What we want to say actually is that another way of saying this is x is equal to the initial position plus the integral from the initial time to the final time of the velocity function. And this is just because, remember, whenever we integrate some derivative, we get the accumulation or the total change of the variable that it's measuring the rate of. So if velocity is the rate of change of position, then integrating velocity will give us the total change in position. Velocity, there's two things we can talk about now. First, we can say that the velocity is the derivative of the position with respect to time. And then we can talk about it in the same way as we did with position, but with acceleration. Or we can talk about it as the integral of an acceleration, I should say. So the integral from some initial time to some final time of the acceleration will give us the change in velocity, or in other words, the final velocity is equal to the initial velocity plus the integral from some initial time to some final time of the acceleration function. And then lastly, we have acceleration, and this one is just defined with its derivative, so the derivative of velocity with respect to time. So this is how we express all of those relationships we talked about before in kind of derivative and integral form. So what we want to talk about here now is faster versus slower. So because the sign positive and negative typically indicates direction, we might say faster or slower, or sometimes you might say where is there a greater speed or a lesser speed or a greater velocity or a lesser velocity. This is typically referring to the magnitude. And so this example should help. So for example, we would typically say that -5 meters per second, if that's VA, and 2 meters per second is equal to VB. We would typically say that VA is greater than VB. Now, technically, 2 is bigger than -5, but because that negative isn't, generally speaking, referring to a negative amount of velocity, it is in some ways, but the interpretation, we're really caring about speed. So when you talk about something being faster or slower or larger or smaller, when we're talking about kinematics specifically, we're referring to absolute values or the magnitude. So in other words, instead of magnitude, you can also say that it's the absolute value. So kind of building on that, if we want to talk about our qualitative descriptors, the first thing, like if we're describing how something's moving, if we want to say whether something's getting closer or farther away, what you want to do is look at the position and is it greater or smaller than the place we care about. So point of interest. So for example, if I start with the position 6 and I'm caring about am I getting closer or farther from the origin, I'm bigger than the origin. Next, look at sign of velocity. Is it positive or negative? And that'll tell you whether you're moving essentially to the right or to the left, right? Because positive will be to the right, negative will be to the left. So then we compare if both same, farther, if opposite, closer. So this, if you think about it, if I'm on the right side, in other words, if my position was greater than my point of interest, and I have a positive velocity, that means I'm continuing to move in the positive direction. So if here is my point of interest, and I'm over here to the right, and I keep moving to the right, I'm going to get farther away. If I'm on the left, and I keep moving to the left, I'm going to get farther away. The reverse of that, if they're opposites, meaning I'm to the right, I have some larger position, but I have a negative velocity, I'm going to get closer. If I have a smaller position and I have a positive velocity, I'm going to get closer. So we're really just looking at same or opposites. Speeding up or slowing down is the same idea. Look at velocity. Is it positive or negative? Look at acceleration. Is it positive or negative? And if they're the same, speeding up. Opposite, slowing down. And this is the same idea. If I'm already at some negative value with my velocity and I make it more negative, I'm getting a bigger speed. If I'm already at some positive value and I make it more positive, I'm getting a bigger speed. If I'm at a negative value, actually let me draw this horizontally as a graph because that'll be easier to see. So if I'm already positive and I get a positive slope, and this is a velocity versus time graph, then I'm going to get farther from zero velocity, so I'm going to get faster. If I'm already at a negative value and I have a negative slope or a negative acceleration, then I'm going to get farther here from the zero velocity, so I'm going to get faster. If I'm positive, but I have a negative acceleration, that means I'm getting closer to 0. So I have I'm slowing down. And if I'm at a negative velocity, but a positive acceleration, a positive slope, that means I'm speeding up. And so this kind of gives us the basic ideas. In the next video, I'm going to show you an example problem.